Hello, this is Yuri Belsky. Today Viktor Birdonosov and I will introduce you to the method of smart little people. This heuristic engages a user in generating ideas by means of sketching groups of smart little people. Are you surprised that sketching may help in idea generation? Don't you know that many famous designers developed their ideas through sketching? Numerous researchers that interviewed famous designers concluded that sketching plays a very important role in conceptual design process and is often related to birth of great design ideas. Have you heard about Gordon Murray, an engineer that was instrumental in designing winning Formula One cars for both Brabham and McLaren teams? Working for McLaren, for example, he designed the most successful Formula One car of all times that you see in this slide. For nearly 30 years, this car holds the record as the most dominant Formula One car ever built. It won 15 out of 16 races in the 1988 Formula One season. Also, it gave Ayrton Senna his first Drivers' Championship. As many other great designers, Gordon Murray did not follow the same design process all the time. He used many heuristics. One of heuristics that worked for him was sketching. In order to develop creative ideas, Gordon Murray changed and improved his sketches many times. He did not rub wrong bits out, but made a new sketch to improve the old one. And, as he said, eventually he threw away 90% of the sketches made before getting to sound solution. The heuristic of smart little people engages users in sketching too. It, though, requires a practitioner to draw little people that solve the problem. Draw smart little people. The method of smart little people consists of 3 steps. Firstly, a user needs to represent a problematic situation with groups of smart little people that fulfill some of the system functions. Then, a practitioner needs to think of the ways to improve the problematic situation by adding new smart little people or by changing behaviors of the existing smart little people. And then, removing some of the existing smart little people as well as changing the existing system can also work. As soon as a user has an idea how smart little people can improve the situation, a user needs to redraw the situation that illustrates this idea explicitly. Remember that it might be necessary to create many drawings. It is recommended to always make a new sketch, even if the idea is related to incremental improvement. When the ideas of improving the situation with smart little people are clear, a user needs to translate the smart little people ideas into practical designs. You may be interested to know how to sketch smart little people. We suggest to follow a traditional representation whilst generating ideas for a couple of early problems to familiarize yourself with the heuristic, and when you are comfortable with the method, to develop your own way of representation. This slide shows one of the possible ways of sketching smart little people. You see 3 people in it. The red person with hands positioned horizontally represents an inflexible or stationary creature. The green that is sketched as running depicts a smart little person that is fully flexible. A behavior of the orange person with hands positioned down is in between that of red and green. It can move, but this movement is enforced by some other part of the system. It is important to note that these smart little people can have additional properties. For example, the red person with standing hair is not only stationary but also magnetic and can be attracted to a magnet. The orange person with a sun-looking head is partly flexible and is also hot. The green person with a cross-like head is electrically charged and can freely move. You see how by changing the person's head we could display additional properties of smart little people. With some imagination you will be able to develop your own representations and symbolism for the smart little people modeling. Let us see how this method can help in modeling a problematic situation and in generating ideas to improve it. You might have seen spirit dispensers that are often used at bars. Most of these spirit dispensers are not automatic and require a barman to open and close a tap to pour a specific amount of alcohol into a glass. As an example of utilization of the heuristic of smart little people, we will consider a classical trees example of an automatic dispenser similar to that shown on the right. Such dispenser is shaped as a bucket that collects a liquid flowing from above. When the amount of liquid in the bucket reaches the critical volume, the dispenser tilts and the collected liquid is poured out of it. This permits to dispense liquid in equal and measured portions. In order for the bucket to tilt only when the appropriate amount of liquid is collected, one of its sides is made much heavier than the other. This side is shown by the brown arrow. Unfortunately, due to such heavy region on one side of the bucket, not all the collected liquid is dispensed. The bucket returns back to the horizontal position with some of the liquid still located inside. Let us model the problematic situation with smart little people. We will use a one-dimensional seesaw to represent the bucket's body with a set of red stationary smart little people on the left-hand side of the fulcrum, representing the heavy part of the bucket, and the orange, partly flexible person falling down to the right-hand side of the seesaw to account for the liquid. Clearly, the model is not perfect, as any model. Let us see whether it is useful, though. Drop by drop, more liquid is collected on the left-hand side of the seesaw. Liquid collection continues until the weight of the liquid is sufficient enough to tilt the seesaw to the right. Once it tilts to the right, liquid is dispensed. Well, the problem of not dispensing all the collected liquid is clearly visible in the picture that has appeared last. As soon as the number of the orange persons on the right-hand side of the seesaw drops below 4, that of the red persons, the seesaw starts tilting back to the left. As a result, one of the orange people that is sketched a little thicker than the rest is unable to leave the seesaw and stays on. As you can see, we have been able to model the actual behavior of the system with help of smart little people. Let us see how the little people can help to improve the situation. Here is the problem once again. What is it we can do to ensure that the thick orange person is dispensed to? Behaviors of which smart little people need change. Imagine that we replaced the red people by the green and ordered them to run towards the fulcrum once the seesaw tilts to the right. Clearly, such behavioral change will resolve the problem. At the time for the last orange person to be dispensed, green people will be close to the fulcrum and therefore the seesaw will not tilt back to the left until all the orange people are dispensed. When the last orange person collected leaves the seesaw, we may request the green people to run back to their original position at the right-hand side of the seesaw, and the collecting-dispensing cycle will start anew. This slide depicts all the stages of the system model with the green smart little people running. Such system ensures that all the collected liquid is dispensed. Now we need to think of practical implementation of the idea. One of the possible implementations is shown on the right. The heavy side of the bucket contains a ball, shown in green, that can freely move back and forth from left to right. Would you agree that this implementation is quite elegant? But it is not the end. Let us see whether we can modify the system with the smart little people in some other way in order to improve its performance. As shown in the sketch at the bottom of this slide, It is proposed to remove some of the red people and to permit the orange people to move to the left side of the seesaw and to occupy the seesaw space up to an installed border that is shown as a thick orange line. Do you think that such modification of the system will improve its performance? Let us model it more accurately and, as an example, use different notations for the smart little people. This will show you that you certainly can have your own symbols to depict the smart little people. Let us represent the red people as the red girls and the orange people as the blue boys. This slide depicts different phases of functioning of this new system. A red girl is permanently located at the left side of the seesaw. Blue boys land on the right side of the seesaw and move towards the new border on the left until the number of the blue boys collected on the right side of the fulcrum exceeds that of the boys plus the girls on the left side of the fulcrum. Then the seesaw tilts to the right and all the boys slide off the seesaw. Looks interesting, isn't it? Practical implementation of such system is shown on the right. So far we have generated ideas using the steps 2.1 and 2.3. We have changed the behavior of red people and made them green. Also, we modified the system and permitted the orange people to move further left. Let us see whether we can in any way use the suggestion of step 2.2 and remove some types of the smart little people altogether. We certainly can remove the red and the green people, but we cannot get rid of the orange. This model the liquid dispensing which cannot be removed. So the only option we have is to keep only the orange people. This means that the orange people need to arrange both accurate collection and dispensation. This can be achieved utilizing a three-dimensional system which contains two separate parts for collecting and dispensing liquid. Let us model such system with blue boys only. The following models, together with possible implementation, are shown in this slide. When the first boy lands onto the collector tilts left and starts collecting liquid in the bucket on the right. When the collector on the right is full, the system tilts to the right. The collected liquid starts dispensing to the right. And at the same time, the bucket on the left starts collecting liquid too. You can see the liquid collecting by the bucket on the left as light blue. And the cycle of collect, dispense continues. Well, you may stop me here and tell me that although the first two ideas we came up with are realistic to make, this one seems too theoretical and cannot be realized. It is simply impossible. Well, to your surprise, a working prototype of this system based on the last idea has been made, and you can see how it works. Engineering is an amazing profession. Engineers often have to create artifacts that have been considered theoretically impossible to make just a few years ago. Hopefully you've liked the working prototype and may ask, why does the method of smart little people work? Why does it help in generating ideas? Well, there are three main reasons. Firstly, modeling the system under improvement with smart little people removes the feel of technicality and helps in framing the situation more accurately. Secondly, availability of a magical smart little people that can do practically everything and possess any characteristic required releases the user from constraints of reality and makes idea generation much more efficient. Thirdly, numerous sketches of system models help to visualize the situation much more accurately and attain a feel of what really happens. In essence, this results in more reframing and in more ideas. Consider using this heuristic. Model complex technical solutions with groups of smart little people, and sketch as many models to improve your system as you can. When some interesting ideas come to mind, think of their practical realization. Remember that many innovators like the Formula One legendary designer Gordon Murray came up with their breakthrough ideas while sketching. So sketch your great ideas with the smart little people. And also, do not forget that you can learn more effective thinking heuristics from the edisons21.com site. Thank you